Hello students, the next question is, the angle of acceptance of an optical fiber is 30 degree when kept in air. Find the angle of acceptance when it is in water of refractive index 1.33. Before we move on to writing data part, let's understand what do we have to find out and what is the formula for that. Okay, find the angle of acceptance, right? What is angle of acceptance? It is the angle at which a ray enters the optical fiber. A ray enters the optical fiber, which is given as, let's say, in general I am saying theta I dash, let's say. Okay, what's the formula for that? It is sine inverse of square root of n1 squared minus n2 squared divided by n0 dash. What are the terms used here? N1 is the refractive index of the core, of the optical fiber. N2 is the refractive index of cladding, and N0 dash is the refractive index of the surrounding medium, meaning the medium in which we have placed the optical fiber, surrounding medium. Now in this numerical there are two media, right? The first one is the air. The second one is the water, whose refractive index is 1.33. So, the data have two parts to it. One for air and the other for water. Okay. Anything corresponding to water, we are writing in terms of theta I dash or n0 dash, n0 dash, something like that. Okay. We represent it using a dash or prime. So, angle of acceptance of optical fiber is 30 degrees when kept in air. We write theta I without a prime, which is equal to 30 degrees. Now the refractive index of air is 1, no? Next, we are supposed to find out the angle of acceptance when it is in water. That is theta I dash is to be found out. What is given? Refractive index of water is given. That is n0 dash is given, which is 1.33. Now what about n1 and n2? Is it given? No, it is not given. We can find it out, right? Because we have another formula relating n1, n2 as well as something called numerical aperture. Numerical aperture is sine of the acceptance angle as well as it is equal to square root of n1 square minus n2 squared. Though we don't know the values of n1 and n2, we know this theta I, right? So from there we can find out numerical aperture. We'll substitute that numerical aperture here. So this equation 1, when we plug in the value of numerical aperture Na, we replace square root by Na, we get theta I dash is sine inverse of numerical aperture divided by n0 dash. So numerical aperture equals sine of theta I is 30 degree, which makes it 0.5. Next, then theta I dash will be sine inverse of 0.5 divided by, what is the refractive index of water? It is 1.33. Sine inverse of 0.5 divided by 1.33 gives us 22.082 degrees. So the angle of acceptance when the fiber optic is placed in water is almost 22 degrees.